Distributed transactions with two-phase commit. Earlier in this class, we talked about parallel databases, and today our topic headline is distributed databases. So what's the difference? Well, remember for parallel databases, we talked about shared memory versus shared disk versus shared nothing architectures. Basically, a distributed database is a shared nothing parallel system, but you might consider a distributed database being over a wider area, so maybe separated by geography with a slower network. But really, we're just talking about a shared nothing environment. What's special about distributed computing as opposed to regular computing? Well, it's got a bunch of features that make distributed computing more complex than working with computers that are co-located. Of course, there is parallel computation, which is a challenge in and of itself. And we have no shared memory or disk, so this is a shared nothing parallel environment. In addition, in distributed systems, we have unreliable networks. So the networks that go across continents or even across data centers can have delay, they can have reordering of messages, and they can have loss of messages or loss of packets. They're sometimes called in networking. So these unreliable networks are a fact of life in distributed systems. Another issue in distributed systems is that the clocks inside the different computers are unsynchronized. It's impossible to get two computers to have their clocks exactly in synchrony. And in fact, it's a fact of relativity in physics that any 2 points in the world will perceive time slightly differently. And so we really can't be sure what time it is at another computer when we're thinking about what to do at our computer. And that introduces complexity. Finally, there's an issue that often isn't allowed in parallel computing, but absolutely happens in distributed computing, which is partial failure. An individual node in a distributed system could be up or down, and we can't, from our perspective, be sure whether that node is up or down. All we can know is that it's been a while since they talked to us. So these are all aspects of distributed computing that set it aside from parallel computing or single-node computing. Leslie Lamport won the Turing Award in 2013 for his work on distributed computing, and he famously was quoted as saying, "A distributed system is one in which the failure of a computer you didn't even know existed can render your own computer unusable." Now, distributed database systems played an important role in the history of distributed computing. The database management systems problems were an influential special case for distributed systems. Turns out, the trickiest part of distributed computing is managing state, or what we call data. And transactions were an early and influential model for dealing with concurrency and parallelism that we get by nature in distributed systems. Also, database management systems were among the first systems to worry about fault handling. And so for all these reasons, distributed databases were among the first and the most influential distributed computing platforms. Now, they are special case distributed databases because they're transactional, and not all programs are written transactionally. And so if you're trying to build distributed systems without transactions, some of the database techniques will not apply. They won't fit your problem. But many of today's most complex distributed systems are, in fact, databases. This includes cloud SQL databases like Google Spanner, AWS Aurora, Microsoft Azure SQL. It also includes NoSQL databases like DynamoDB, Cassandra, MongoDB, Couchbase. All of these are complex distributed systems that are, in fact, databases. In our lecture today, we're going to focus on concurrency control and recovery for transactional distributed databases. You already know how to do query processing in a distributed system. We learned that in our parallel database discussion. Today, we're focusing on concurrency and recovery.